Welcome to Presentation 23. Today we're going to be talking about the display 16 by 2. This means that this is a display that has a 2 row and can display 16 characters, 16 columns. I should say that this is one of the simplest display to program, because all you have to do is send it basically as ASCII characters, and it will display it at the location you want. Now, as usual, I like to show our architecture. Displays are in layer 3, and in this case, we're going to be using the IO port framework only to make this work. Now, let's look at the agenda. So first, I'll give you an idea about the display, a little description. Then we'll go through the data sheet. As usually, we always go to a data sheet where I get all the information, and you can also get it. Next, we look at the display modes, message types, display commands. Then we're going to do a data transfer timeline, and then we'll go through a couple of sample programs. The last subject would be custom characters, and we'll end up with a third example program. So let's start with the description. So I have here the picture of the front of the display and the back of the display. Now, why do I show you the back of the display? Because there is some very important information here. This number, basically, it tells you what is that you bought. So what you bought, or I bought, is a 16 character 2 lines display, and it has a Hitachi HD44780 controller. This number is very important because that's we need to get the data sheet for that controller, and that's going to show you how to program this particular display. Next, I'm going to show you an idea of the pins. So we're going to have a pin for the ground power, then a pin for the contrast, that would be pin number 3. Now, the important thing about this is that you have to know that you have to connect a potentiometer to drive the pin 3. Then you have the register select, read write enables, the transmission enable, and then you have 7 lines, actually 8 lines, D0 through D7. That's where you're going to put the value of the ASCII code that you want to transmit to the display from the controller. And finally, you have a couple of lines for ground and power for the black light of the display. So let's start with the data sheet. I'm just going to give you spend a little bit of time so you kind of get the flavor of what you can expect to get from the data sheet. This document contains all the information you need to program your display. I'm just going to go through some of these pages so you get an idea of what's contained here, or the type of information you would get from here. So right off on the first page, it tells you what are the features. It lets you know exactly what is it that you bought. So let's look at page 8 now. Page 8 contains all the definition for your pins. So if you want to know what each of the pins do, page 8 has those definitions. Now let's go to page 23. Page 23 contains the information on exactly what's the value of your parameters when your display powers up or gets reset. For example, we would say the cursor is off, the blinking is off, and so forth and so on. So when you power up, it tells you exactly what is it that you need to set up. Next, on page 24, we have all the commands that you can send to your display. For example, if you send a 1, then that would send a command for the displays to clear. The entire display is clear. So here you have all the commands that you can send to your display. Now let's go to page 45. Now this page contains the initialization, how you initialize your display. When you power up your display, you must initialize it, otherwise it's not going to do anything. And how to initialize it is described in each of the controller documents. So let's look at this one. So it tells you here, okay, 15 milliseconds after power up, send a binary 1-1. Wait 4.1 millisecond, and then send another binary 1-1. Then wait 100 milliseconds, and then send your finally message 1-1, which is a 3. Next, it send the command to display off, command to display clear, and then the command to entry mode. So now the important of this portion of my presentation is to let you know that when you buy a display, it is very important, or the first step I should say, is to figure out what is the controller. Next, you have to get the controller document, and that's going to give you all the information you need about the pins, how to initialize the display, the commands to send. So with that, let's get back to our presentation. So that was really good information, and that's always the first place you have to go. So now let's look at the LCD modes. So let's see, it can be configured to 2 different modes. One is the 4-bit mode, and the other one is the 8-bit mode. In the 8-bit mode, we send the 8-bit data directly in one stroke, 8 data lines. So 8-bit mode, we have to hook up 8 data lines from the processor to the display, and we send the ASCII code all at once. Now we have a 4-bit mode. It's simpler in the sense that we don't have so many wires hooked up. So we only have 4 wires hooked up. In the 4-bit mode, we send the data nibble by nibble. So we have to send 4 by 4. So before you see, so it takes 2 transmissions to send a ASCII character. With 8-bit mode, it takes one transmission. And the first upper nibbles is sent in data 4 to 7, and then the lower nibble is sent. Of course, 4 data lines needed, as I noted. Now, 8-bit mode is faster than 4-bit mode, but it 8 data lines to connect to the microcontroller opposed to 4. And that makes a big deal. However, I'm going to use the 8-bit mode for all of my examples. Now let's look at the message types. So we have actually two types of messages. The first type of message is a command. A command is an instruction sent to the LCD that controls how it behaves, not what it displays. For example, would be clear the screen, move the cursor, turn the display on and off. On the other hand, data defines what appears in the displays, for example, the ASCII code. So let's look at the flowchart to see exactly how this would work. So always we have to set first a command. Tell the display, hey, this is what I'm going to be doing. So let's look, for example, at the initialization case. So we send the commands for initializations, and we continue to send commands until we've initialized our display. And you'll see that, by the way, on the example programs. So once we send all the commands to initialize the display, then we transmit a command to set the cursor in a location. Basically, by that I mean is you tell the display where I want you to start displaying the characters. Then we transmit the data to be displayed as one ASCII character at a time. And then we continue to transmit until we've completed our transmission, and then we stop. So basically we set a command to say clear the screen. We're going to send you, this is what I want you to do. Or I'm going to be sending you something I want you to display. Then you set it what you want to display. And then when you're done, you just stop. So let's look at the commands that you can send. And again, all this stuff comes from the data sheet that I showed you. So we have the basic commands. That's to clear the display or return home. Move the cursor to 0, 0, basically. We have entry mode commands. We decrement the cursor. That means shift to the left. And don't forget, when you shift to the left the cursor, that's where the next character is going to be displayed. Or you can shift the cursor to the right, move the cursor to the right, and that's where you're going to display your next character. So you send the command, hey, move it to the right, and then you send the data, and it's going to place it in the new locations. Then we have the display control commands. And that's where we're going to say display off, cursor off. Because otherwise you have this white line on or blinking. You may not want that. We have display on, cursor off, and that's why generally I like to get the display off and the display on and the cursor off. Then we have display on and cursor on. And finally we have the display on and the cursor blinking. Let's continue with the commands. These are the cursor and display shift command. So we have move cursor to the left, move cursor to the right, shift entire display left, and shift entire display right. Next we have function set command. So this is the one that we're going to use if we want to use a 4-bit mode 1 line display, or we want 4-bit mode 2 lines, or we want 8-bit mode. Now, the 8-bit means we're going to have 8 cables connected and one line display. In our case, we're going to have the 8-bit mode. I'm going to have the 8 bits so I can send the one character at a time, and I'm going to have 2 rows to be displayed. And finally we have the CG-RAM and DD-RAM control, and that's the address. So we're going to use this command when we're for our defined characters, custom characters, which I'll show you. And then the 80 address, it moves the cursor to a specific position. So all these commands, I'm going to use them in our example, so they are going to become clear exactly what they do. This is just to give you a general idea of what's out there. So let's look at the a data transmission. So the first thing you have to define is what are you sending? It's a command or data. Don't forget, you send first the command followed by the data that supports that command. So 0 is going to be a command, and 1 is going to be data. And then you stay where you're going to write to the display or you're going to read from the display. Usually we write to the display. And as a matter of fact, in a lot of when I do my connections, I connect this to ground. Next, so first thing we do is data command, then we place the information on the ports D0 to D7. I mean, these are, yes, you can select any port, could be C0 to C7. This defines data 0 to data 7. It's not associated with our ports. Okay, so we decide we're going to say data command, then we put the data into the register, a port in this case. Then we're going to set the enable to high, wait 1 milliseconds, and then set the enable to low. And when we do that, the data on D0 to D7 will be transferred. And then we wait 37 milliseconds. So the site, the data command, put the data where it belongs, and then the enable goes from high to low, and we're done. Message goes through. Okay, so let's go to our first example program. So what are we going to do? So what I did is I put in the register select, which is this data command is going to go on port C0. Then the read write, which is always going to be right, is going to go on port C1. Next, the enable is going to be port PC2. So now, so this is the one we go from high to low to get the data transfer, and this is where we set up whether this is a command or data, and this is something that's always going to be right. Now we have to, then we place our data in port PD0 through port PD7. And then we have the black light and the ground MBC for black light. And this is the potentiometer. So let's go through this example statement. So we're going to initialize our display. So we learned how to do that. The information we got it from the data sheet. Next, we're going to display the following. In line 1, we're going to display hello world. And then in line 2, we're going to display LCD sample 2. Even though this is example 1, we're going to display sample 2. So let's get going with the example. First, I will give you a global view of the program, and then I will get into the details. Here we have the signal register select, read write, and enable being assigned to pins 0, 1, 2 of port C. Now the init ports routine, what it does is initialize those ports. Next, we have a routine to write commands, followed by routine to write data. Then we have the init LCD routine. Here we have a cursor location routine. What it does is decides whether the character is going to be displayed on the first column or the second column of the display and the locations. Here we have the write string. What it does is parses a string and it sends character by character, or I should say ASCII character by ASCII character to the display. And finally, we have the main routine. The init ports routine, what it does is sets the RS signal, RW signal, and EN signal in port C to output. That would be the register select, read write, and enable signals, those to output. Next, we have the write command. What the write command does is sets the RS signal to 0 in port C. Next, it sets the RW signal also to 0. Now, the port D is set to output. Next, the command that we got from this input gets loaded into port D, which has been set to output. And finally, what we do here is we stroke the enable signal. So the enable signal goes from one delay of 1 milliseconds, and then it goes to 0. Next, we delay for 50 milliseconds. Now the write data is fairly similar to the write command. The main difference is that the register select RS signal is set to 1. Next, the write read signal is set to 0, which means write. Followed by the port D is set all to output, and the data obtained is loaded into that register. And finally, again, we stroke the enabled signal. The enabled signal goes from 1, delays 3 milliseconds, then it goes to 0, and then we wait 50 milliseconds before exiting this routine. Now here we have the init LCD. Now the material for this routine was extracted directly from the controller data sheet. So what we do here is we set the register select to 0, the enable to 0, wait 20 milliseconds, then we write the command 30, wait 5 milliseconds, write 30 again, wait 1 milliseconds, and then we write 30 for last time, and we wait 10 milliseconds. Now we send the command to the display telling it that we're going to have 2 lines, 8 bits each line, followed by the hex 0C command, which turns on the display and turns off the cursor. Next, we clear the screen, and finally we set it to the entry mode that we desire, which in this case is going to be hex 06, which means the cursor, move the cursor right after each characters. So again, all this routine the material was obtained from the controller data sheet. Okay, here we have the cursor locations. So we get the row and column where we want to place where we want our character to start. So according to the row, we can place it in row 1 on row 2. If it's in row 1, then we have to send the hex 80 command. If it's in row 2, then we have to send the C0 hex command. Now in this write command, we write for the column 1 the 080 hex, and we add the column where we want to start. So this is the input we got of the column we added. If we want to write the character in column 2, then what we do is we write, like I mentioned, the command hex C0, and we add the column. Next, we have the write string. What this does is we get as an input a string, and then it parses the screen, each ASCII character, and sends it to be display, write data into the display. Now what we have here is the main routine, what we do, we initialize the port, we initialize the LCD, we write the command to clear the screen, then we write the location, which is the command where we want to start our writing, which is position 1, column 0, and here we have the write string, which is going to send the write data. Next, we send the command where we want the cursor to be located. That would be in row 2, column 4. Don't forget that we start counting the columns from 0, and then we write the sample command. So let me backtrack and give you one more view really quick. So we initialize ports, we write commands, we write data, we initialize the port, we place our cursor where we want the data to be written, we parse a string, and then we go to the main program that takes care of everything. So let's look at the output. So this is the display. Like I noted, we start in column 0, row 1, column 0. So here we have hello world. Then we went to the second row, and we started in column 4. So we have 0, 1, 2, 3, and 4, and that's where the sample 2 starts. So this gives you a good idea how the program works, and let's continue with our presentation. Okay, so here we saw the display in action. So let's go to a second example. So the same configuration as before. Don't have to do anything to the how we hooked up the LCD and the microcontroller. So let's read the statement for this program. So we're going to initialize our 16:2 LCD. Next, we're going to display the following. In the first line, we're going to display sample 3, asterisk sample 3. Next, in line 2, we're going to show a arrow and then the words slow down. Now, the line 2, we're going to make it scroll. So we have sample 3 and then we have slow down scrolling. So you get, a lot of these displays are kind of small, so things scroll. So I figure out, I'll just give you an example with things scrolling. Before I get to the program and the explanation of the program, I would like to spend a little bit of time talking about the algorithm I'm going to use for scrolling the messages. So what I'm trying to represent here is a string message. The string message says slow space, down space, drive space, with space, caution. Now this string has 28 elements. So basically it's an array between 0 and 27. So the first time I show the message, I'm going to go between position 0 and 14. The next time I show the message, and to show that it's scrolling, I'm going to show positions between 1 and 16. Next, I'll show between 2 and 17. And so forth and so on till I get to the position 12. When I get to the position 12, I'm going to show the elements between 12 and 27. Now, once I get to an offset 13, then I have to go back to 0 because I got to the end of the array, to the end of the string. So how do I accomplish this? So let's look at this snippet of code that is going to go on the main program. So let's forget about this first line. Let's look at the second one, the offset. The offset is going to be equal to the last offset plus 1. And then I'm going to use the module operation to, once I get to the end of the message, I end up back to 0. So basically, when I get to 27, which is the last element, then I add 1, which is 28, and the string length is 28, so that gives me a result of 0. So the offset basically goes back to 0. It can only go as high as 27, and then it goes back to 0. So that's how I'm handling the offset between 0 and 27. Now let's look how we're handling the displays. So I call a routine called LCD scroll window. So it has two elements, the message and the offset. Now this is how I calculate the offset. Now when I define the offset at the beginning of the program, I set it to 0. So let's go to the LCD scroll window. So the first thing I do is I go to cursor location 2, 0. So I'm starting second line position 0. And then I go and start printing the ASCII character. It's from 0 to 16. That's all these characters here. So as I showed before in this graph, this is going to work fine until I get to position 12. Because once I get to position 12, the next position 13 has to go back to 0. So let's look at what happened when I get to position 12. So after the position 12, the offset is going to be 13. And let's assume that I goes between 0 and 15. Which is the last value that can have. So then the value of the character that I'm going to be sent is going to be message, and the position of the string is going to be 13 plus 15. That 13 is the offset, 15 is the value I get from the do loop, and that's 28. And when I do module 28, that's going to get me back to message 0. So that's how I make sure I don't go beyond the boundary of the array in the main program or in the routine. So let's go to the code and see how we accomplish this. So this is the same code that we looked at before, but I've added the routine needed to do the scrolling. So we initialize the port, we have something to write commands, we have a routine to write data, we have a routine to initialize the LCD, I should say. Next, we have the cursor location and the write message. So that's exactly as before. I haven't changed anything there. So now what I added was the LCD scroll window, which I noted is going to, we gets the message plus the offset. So what we do is we always start at column 2, position 0. And we go from 0 to 15. And this is going to go incrementing till we get to the point where this offset plus the value of the loop reach the whatever number, the length of our message, and then we go back to 0. So let's look at the main program. So what we have here is the offset, like I noted, starts in 0. So then we initialize our ports, initialize the LCD, and then this is the message that we're going to transmit. It's going to say, it's going to have an arrow, and then it's going to say slow down, a space, and that's it. So that's the message that's going to scroll. Then we have here a command to clear the screen. Now in the first row of the display, we're going to put in the sample 3 message. So it's in row 1 and we start at column 2. Now for the while loop, we're going to start sending a message with the offset of 0. And then we have our offset. Now the way we have our offset is going to guarantee that we don't go beyond the length of the string. And then we have a delay, and then we do this over and over. So let's look at the output of this program. So you can see here how things start scrolling. Things start disappearing here and start appearing here. So this routine can go forever. However, I just stopped it because otherwise we would be here forever. So that gives you an idea of how to use the display with scrolling. And so we can go ahead to our presentation and continue with the final example. Okay, so let's continue. So what we're going to talk about now is a character generator RAM. That's what you use to create your custom characters. Now the CG RAM can store up to 8 custom characters. So the steps to implement the custom character are as follows. First, you define a character pattern. Each character is going to be 8 bytes per character. Next, you have to take that character that you've created a microcontroller and load it into the CG RAM, which is located in the display. So you have to transmit that parameter from your microcontroller to the display. Then to display the custom character, you have to write to the position where you store it. The position is going to be between 0 and 7. So let me show you exactly how we do this. First, you send the command 40 hex plus the location multiplied by 8. And I'll explain why we need to add this location times 8. This basically tells the LCD I am going to define a custom character at a particular location. Next, you send the 8 bytes of data. This defines the shape, row by row, of your custom symbol. You send row by row of your custom symbol. To display it, set the cursor using the command 080. So basically you put the cursor where you want it to be displayed, and then you follow it by the location of the custom character to be displayed. So these are the locations. I'm trying to explain why we need the hex 40 plus location times 8. So the way it works, if you set only the 40, then the custom character is going to be stored in location 0, which is at address 40. The next time, if you want to store a different character, then you have to store it in location 48. So how we do that? So we send the 40 plus 1 times 8, which gets you to location 48. Now, if you want to store it on a third character, then you have to send you want to store in location 56. So how we do that? Again, in a generic way, we send the 40 plus 8 times 2, which is the location 2, 8 times 2, 16 plus 40, it gets you to the 56. So that's how you do it. So instead of sending the 40, 48, 56, 64, and you have to memorize that, we use this location times 8, and then you can use the location calling it 0, 1, 2, 3, 4, 5, 6, 7, which is more convenient. So let's go to the sample program. So what we want to do is we initialize the display to a 16 by 2. We want to initialize our 16 by 2 display, I should say, sorry. Next, we have to create our custom character. We're going to create 2 custom characters. One I call aeroplane, the other one I call you smiley. Let's see how I decided the aeroplane to create the aeroplane. So the first line is going to be all zeros. Now where I have a 1, that's where things are going to light up. 0, nothing happens. So where I have the 1s is where the display is going to light up. So basically 0, nothing. 4 is going to put a light up this LED. Then 0E is going to light up this 3. Then I do 4 again. And then 1F hex is going to light up all this, and so forth and so on. But you'll see it on the display. Now the next one is the smile. And the smile is going to be something like this. And this shows you, I put it in binary to just have something different. So that's what it looks like. So item 1 is initialize your display. Item 2, display the following custom character. You have to create them and display them. And then we want in line 1 to display the hello world as a header. And then the custom character, which are these characters. So I'll probably do the airplane smiley, so we'll see 4. So let's look at the code. For example, 3, we're going to be reusing the routines that we developed for example program 1 and 2, which are the need ports, write command, write data, initialize LCD, cursor location, write string, LCD, scroll windows. Those routines we developed for example 1 and 2, and basically what we're doing is adding on what's needed for example 3. So in what we're doing here, we're going to, the only new routine is create symbol. Now the purpose of this routine is to get the symbol that we've created and transmit it to the display so it can be stored there, and we know where we stored it so we can get it later on. So this is how we're going to do it. First line of code, we're going to send a command which is hex 40 plus the location where we want our symbol to be stored times 8. Next, after sending the command, we send the actual symbol. So the symbol is it's 8 words of 8-bit each. So that's what this loop does. Now once this create symbol routine has been executed, then there is a symbol stored in the display that we can go and get it at any time. So let's go to the main routine. Here we have the symbols that are created. One is called aeroplane and the other one is called smiley. Next we initialize the port, initialize LCD as before. Now the step here, what we're going to do, we're going to create our symbols. So basically these routines, as I noted, it's going to get the symbol, transfer it to the LCD so it can be stored, so we can get it when we want it to be displayed. So here we create the airplane and the smiley. So both symbols have been transmitted, stored on the display in location 0 and 1. Next, what we do, we're going to put a header in our display. We're going to, the first line of the display is going to say asterisk, custom symbol, asterisk. Now, once we accomplish that, then the next thing we're going to do is we're going to move to the cursor to location 2, 4 in this case, and we're going to display the symbol in location 0, which is the aeroplane. Next, we move the cursor to the right 2 positions, and then we're going to display symbol that is stored in location 1 on the display, which is the smiley. Then we move the cursor 2 more positions, and again we display the airplane once, move to position, and the smiley once more. So let's see what's the output. And so here we have it. We have the custom symbol in the first row. So we have asterisk, custom symbol. And next we have our airplane, 2 spaces, smiley face, 2 spaces, airplane, 2 spaces, smiley face. So this shows you how to program so you can create a custom symbol and how you can later on display it. So with that, we can continue to our presentation. Okay, so let's continue. We finally got to the summary. So what we did today, I gave you a description of this 16:2 display. We looked at the data sheet. We looked at the display modes, message types, display commands, data transfer. Then we did the data transfer timelines. We looked at custom characters. And finally, we went to program for each of this stuff. So we show how to display something, how to display it with something scrolling, and then how to create and display a custom a custom symbol. So this gets us to the end. I hope you've enjoyed this presentation, and hopefully I'll be able to make many more. So again, thank you for taking the time to listen.